All right, so here we're going to look at solving quadratic equations by completing the square. The why is completing the square can solve any quadratic equation. Our previous methods have been limited, and we'll talk about what those previous methods are and see kind of where they fell short. All right, so students typically do not like completing the square, but let's remind ourselves why solving quadratics is important for us to stay motivated, because we're still talking about some of the concepts that we enjoyed. If you think back to when we got hyped for Chapter 3. And anytime we're working with quadratics, that's our projectile motion. So that's us launching something up into the air, figuring out how high did it go, how far did it go. And on projectile motion, we looked at football punts, we looked at juggling. We've done some with from a business standpoint. We've done some with business where we're looking for, maximizing profit or minimizing expenses and break-even points. So that's all the stuff that's still dealing with quadratics. Completing the square could ultimately help us address some of those concepts. All right, so that's just to keep you motivated, because when people get to completing the square, they typically want to, quit and kind of zone out. All right, now if you struggle with this section, in the notes and the homework, you could rewatch this video or come see me for help, because it's not too bad. It's just when you only spend a little bit of time, it can get a little tricky. All right, so here's what we're going to do. We're going to go through and look at some of our previous methods first, and then we're going to learn our new method today. And this is talking about here, why we learned in this one, because we already have actually 3 other methods to solve quadratics, but then we'll get to see why we do in fact need completing the square. All right? So if I asked you to solve x squared minus 9 by factoring, your first step would have been to get it factored. Now this one would factor to x plus 3, x minus 3, because the middle term there is 0x, so I need numbers that add to 0 and also multiply to negative 9. And then you would have taken both pieces and set them up equal to 0. And then when you solve, you'd have gotten a solution of negative 3 and positive 3. So that's how you could have solved that equation by factoring. We also could have solved it with the square root property. The square root property is only usable when your b is equal to 0. All right, so do remember that. And you'll notice that there's 0 x's in there. All right. Now the way we use the square root property is the goal was to get x squared is equal to a number. So on this one, I'd add 9 to both sides, and then use square root. So I'll square root here, square root there. And if you recall, anytime you use a square root in an equation context, you do need the plus or minus. All right, and this positive and negative 3, that's the exact same positive and negative 3 that you have right there. All right, and that's why you need that plus or minus symbol, because you can see when factoring that you get 2 solutions. So when you use square root method, which is the exact same equation, you should still be getting those same answers. All right? And then we also saw how to solve quadratics with graphs. And the way we did that was we made tables. Now I'm going to make this table for us just for time's sake. This one's vertex is at 0, negative 9, which is actually off the page. And then as you start to do other numbers, you'd get a negative 8. Here you would get a negative 5. And if you filled these values out, you would see that this is indeed correct. But when you got to negative 3 and positive 3, and you plugged 3 or negative 3 into the equation, you would have found that your y-coordinate is 0. And that's what solutions were. Solutions were x-intercepts. And we already saw from those other methods that we crossed over at negative 3 and positive 3, and then also those fit there. So there's kind of our graph. Now it goes off the page, but that's okay. All right, so there's us finding it on a graph. The solutions are the 2 spots where you cross over that x-axis. All right? So there's 3 different methods right there. All 3 of them work. And sorry, this value here in the table should be a 2. 2. Okay. So we have these different methods here. And all 3 of them work. Right? So you might be wondering, why do we need a new one? Well, and in terms of which one we prefer, some people like factoring. So here's where you can kind of think. Now, people typically like the square root method best because it's easy. You're just solving an equation. However, do keep in mind you can only use it when b is equal to 0. And a lot of times b isn't equal to 0. There's other times where maybe I give you like an x squared plus 11x plus 30. That one you couldn't use the square root method, but you could factor it pretty easy to x plus 5x plus 6. And people who are good at factoring typically enjoy factoring. Graphing's people's least favorite because it takes more time. So we have all 3 of those methods. 2 of them are not so bad. But here's why we need a new method. So let's come over and take a look here at this. So it says solve each using the square root property if possible. So this one is possible. All right, I'm going to simply add 25 to both sides here. When I add 25 onto both sides, we get 61. And there's no b term, right? Notice that there was 0 x's in there. So I could square root both sides and get that x is equal to plus or minus the square root of 61. However, when you look at one like this, what you might recognize is, hey, first off, it's not set up equal to 0. So now we're talking about this next one. If you tried to factor it, you would want to get it set up to 0 by subtracting 100 from both sides. So that's going to give us a minus 64 is equal to 0. All right. Now, I can't use the square root method here because of this b value. Right? There's no way I'd ever be able to get this to x squared is equal to a number because there's a b value in the way. So my next step would be trying to factor it. And if you try to factor this, because we know it's x and x, you'd be looking for numbers that multiply together to give you a negative 64 that add to 6. And there's actually not a combination for that. So this one would not be factorable, which means we're going to need a new method. If you tried to solve this one by graphing, your table would never have a 0 show up. This one's actually going to have a square root answer, similar to this one, like how that one had a square root answer. And that's where our new method needs to come into play. It's where it's not factorable. I can't use the square root method because there's a b term. We need a new method. And our new method is called completing the square. So it's a method used to manipulate a quadratic equation so that one side is a perfect square. And that's why it's called completing the square, because we're going to need to make one side a perfect square. All right? And then once one side is a perfect square, then we're going to be able to use the old square root property to solve the equation. Now, there is quite a process to this, but we're going to practice it several times, and once you get good at it, it's not so bad. Also, as a heads up, this method will be beneficial to you next chapter. It'll save you some time. This is ultimately going to be our alternative to use when we don't want to use the quadratic formula, which we'll learn about next section. Now, one thing here is that we only want to use completing the square. I'm going to abbreviate here. Only use completing the square when your a is equal to 1. And you'll notice that the example that we're about to do has that as the case. Then all the examples I asked you to use complete the square on is when a is only equal to 1. So that would be, like a 1x squared, and then all that other stuff. You can use it when it's 2 or another number, but it gets more complicated, and then at that point it would be faster to use the quadratic formula. Learn next section. All right, so we saw this one on the other side was not factorable. All right, so we need to solve this one by completing this square. Now, we do that by first off clearing your c value. So we already determined that this method didn't work. So let's clear that c value out. Even though 36 is a perfect square, it's not actually the number that we need. So when I subtract 36 from both sides, leave myself a little space. Here is a 64. And to determine what number goes here, we do our completing the square process of split the 6 up into 2 equal pieces, figure out what those 2 pieces multiply to, which is a 9, and add that to both sides. Once you add it to both sides, the left-hand side factors to x plus 3 squared, and it's equal here to a 73. All right, we've reached the goal of getting x squared is equal to a number. So now when we go and square root both sides, you'll get that x plus 3 is equal to plus or minus square root of 73. And then when you take the final step of subtracting 3 onto both sides, there would be your final answer. Now, if 73 had some perfect squares in it, we would continue to simplify it. It does not, though, so that would be our grand final answer there. So when we're completing the square, the idea is to change the quadratic into a perfect square trinomial. All right? So we're going to look and see, well, what really completes a square? So what I mean by this is that we want to get something to factor to the same thing twice so that we can shrink it down to that concept squared. All right, and so this part here is going to teach us how to find what numbers make something a perfect square trinomial. All right, and it's very easy. If I want this to factor to the same thing twice, we know from our factoring skills that this number has to come from those 2 spots being added together. So those 2 spots have to add to 10. And if we need them to complete the square, we know they have to be the exact same number. So the same number added to itself that's 10 is 5. Right? 5 plus 5 is 10. So what that tells us now is that our missing term here, which will come from 5 times 5, is a 25. All right? So we just completed that square. What this would factor to now is x plus 5 squared. All right? And that's the process. It's literally as easy as looking at your middle term and splitting it up into 2 pieces. So this one is 7 and 7. And then to find that missing term, all you have to do is multiply. So 7 times 7 would make this one 49. And this would now factor to x plus 7 squared. All right? All right. So now that you all are seeing the pattern here, this one would go to x minus 9 twice, which then means negative 9 times negative 9 is an 81. This one here, you split the 20 into 2 groups of 10. 10 times 10 is 100. So as you may have noticed, there's a little formula here that allows us to do this. What we were doing was we were taking our middle term and we were splitting it into 2 pieces. Right, 14 split up into the 7 and 7. Any of those, we took the middle term, split it up into 2 pieces, and then we simply squared that number, right? Because we multiplied it by itself. So that's how you find your missing C term. Okay? So, we're now going to solve by completing the square. And we're going to go back to that one on the other page too. Now, what we're going to need to do here first, though, and this gets people a lot of easy partial credit, is first we're going to need to move the C term. The C term is rarely the number that we need. And then, just like we did above, we'll use that process to make our scenario a perfect square. All right? So we'll go ahead and do this one since we're here, and then we'll flip back over to that one on the other side. All right? So looking at this guy, I already mentioned the first step is to clear your C term, which would look like this. So I'm going to get my 5 away. Now, after you do that, leave yourself some space, because just like above, we need to now fill in what number goes here. All right? And to do that, same concept as up above. You know, this is going to factor to x minus 6 and x minus 6, and that comes from splitting up the negative 12 into 2 equal pieces. Now, negative 6 times negative 6 is a positive 36. Now, do keep in mind, we're working with an equation here, so I can't just add 36 to one side. I need to also add 36 to this side as well. So don't forget about that step. That's the one that people common forget. But we can't just go around adding whatever we want. What we do to one side, we must do to the other. All right? Which this now takes us to x minus 6 squared is equal to, now, for us here, sorry, this is, we missed here that this was all the way back a negative 5. All right, from right there. All right, so we have negative 5 plus 36 to get us a 31. So remember from the square root method that the goal is to get x squared is equal to a number. All right, and we've done that. Now ours is a little more complicated because it's kind of a whole term that's being squared, but the concept is the same. Once we get it right here, the next step is to square root both sides, because that frees up my x. And it leaves us with a plus or minus square root of 31. And then the final step here would be to add 6 onto both sides. And we get our final answer of x is equal to 6 plus or minus the square root of 31. Now, what this means is that this original scenario was not factorable. Right? If I rewrite that original scenario, which was x squared minus 12x plus 5, if you look back at the original scenario, it was not factorable. Right? There are no numbers that multiply to 5 that also add to negative 12. So factoring was off the table. The only method we had to solve this one was completing the square. And you can see why it wasn't factorable, because the answer has a square root in it. So what completing the square is good for is solving quadratics that aren't factorable and where a is 1. All right? And it can solve them like that. Now, we'll learn the quadratic formula as well. You'll need to know how to do the completing the square for this chapter, but then after that you'd be able to decide if you wanted to continue with it or not. So let's go back to the one that we were previously stumped on and complete it.